So this is a bunch of hats, and we're going to talk about how we can use the graph of a linear model to estimate the production costs for a small hat making business. Have you ever thought about that as a career? Might be better than like truck driver. I don't know. This is Algebra 1, 4.7. So I want to show you just various forms of an equation of a line. And what we're going to talk about today is the slope-intercept form, which is the y equals mx plus b. M is the slope of the line, and b is the y-intercept. Now, a standard form of a line would be ax plus by equals c, where a, b, and c are integers, and a is greater than 0, and a must be positive. And then there's also the point slope form, which is y minus y1, which equals m, and in parentheses, x plus x1. And here the m equals the slope of the line, and x1 and y1 is any point. So we've talked about this one before. So today, this lesson is on the slope-intercept form right there. But I just wanted you to be aware of the three different lines here. So this is the y equals mx plus b. The m is the slope. The b is the y-intercept where it crosses the y-axis. So the y is where it crosses the sky, because the y goes to the sky. Again, here we have the same thing. The m here is the slope. That's how much it changes. That's the rise over the run. And the b is the y-intercept. It always has a 0 for the x value, and then the b value is going to be where it crosses that y-axis. This down here shows you the kind of the same thing, where the m is the slope. If the slope is 2, then it shows you how much change, and so I will talk about that in a minute. But this equation here, y equals mx plus b, turns out and looks like this by the time we work it through. Y equals 2x plus 3, where 2, this purple 2 here, is the amount of the slope, and 3 is where it's going to cross right here on the y-intercept. So how would you graph y equals 2x plus 3? And the slope-intercept form, which I just talked about, is y equals mx plus b. And so let's say, so here we see that the slope is 2, and that means you're going to go up 2, so it's 2 over 1, because there's nothing underneath the 2. Sometimes you have a fraction that's already there. But in this case, if it's just one number, then you know it's over 1. So 2 means you go up 2. If it was a negative 2, it would mean you would go down 2. And a 1, you're going to go 1 over 1. And then the y-intercept is 3. So we see right here this orange. So right here we have the orange dot indicates the 0, 3. 0 is for the x-axis, which is 0, where the y, where it's going to cross, the y-intercept crosses the y-axis. So we have 0 here. We're going to go up 2 and over 1, and then up 2 and over 1, up 2, over 1. That continues like that. And we could do our line, but I can't make my stylus to a straight line. I've been practicing. I tried a ruler and it still won't work. So it just is all shaky and I don't know why. I'll have to work on that. I just want you to see here, just to be aware, if y equals 2x plus 3, then we have this formula. I'm not going to address it right now. I just want you to recognize it, that m plus b minus b over 1 minus 0 equals m. So we'll talk about this later, but we just wanted you to see it at the moment. So here we have, it says find the slope and the y-intercept of 2x minus y equals negative 3. Don't forget the negatives on this. And remember when, negative times a negative is a positive, and some of that stuff as we go along. So it says rewrite in slope-intercept form. That means that you're going to put the equation y equals. So slope-intercept form means y equals. In this case, we're asked to put into slope-intercept form 2x minus y equals negative 3. And so we have to just solve the problem like we normally would. No big deal. We subtract 2x, negative 2x from both sides. We end up with negative y equals negative 3 minus 2x. We're going to divide both sides by negative 1. And that will leave us with y equals, and then this is the important thing to remember, is to put it in slope-intercept form. Not only does it have to be y equals, but then you have to put the x and the coefficient with that after the equal sign. So we have to reformat our equation, change the order. In his case, it would be 2x plus 3. Our negatives got taken away. And then the slope is 2, and we have it in the format, and the 3 is the y-intercept, and we have it in the format that is the slope-intercept form, y equals mx plus b. So this says graph an equation in slope-intercept form. Graph the equation y equals negative 3x plus 2. We see here it's already in slope-intercept form. It's just asking us to graph it. We know the slope is going to be negative 3 and the y-intercept is going to be 2. If it's just a whole number that's right here, we want to, you just know that it's going to be over 1. So that, this negative 3, well, it's there, it just means that it's over 1 if there's nothing there. Sometimes there's a fraction there, and so you just can go with that. In this case, the bottom part is missing, and you just have to know because we want the rise and the run to show up, which is down here. Negative 3 is the rise. That means we're going to go 3 down, and 1 is the run. We're going to go 1 to the right because that's positive. And it wants you to plot the point 0b, and b always represents the y-intercept, and that is 2. So b is 2. And let me go to the next page. So here, b equals 2, it's in pink, and you can see that right there, 0, 2 is right there. And then I now can use my slope-intercept, my rise over run to figure out what to do next. So now I'm going to go, if this was where we were, this was the slope-intercept, so now I'm going to go down 3, 1, 2, 3, and over 1. And that would be the next point. And then the next point would be 1, 2, 3 down, and 1 over. And I would keep doing that, and I can plot my points. And when you go up, though, you have to work backwards to do the same thing. So here we have another equation, y equals negative 2x plus 3. We know the slope is negative 2, the y-intercept is 3. We can find our y-intercept is the green dot here. We're going to go down 2 and over 1, down 2, over 1, down 2, over 1, and the reverse up here. And then I could draw a straight line through this, but as I've already told you, I cannot draw a straight line on here, so that's the best I can do, sorry. Here we have x equals 4x minus 5. The slope is 4, and the y-intercept is negative 5. So here is my negative 5. I'm going to go up 4 and over 1. So I'm going to go 1, 2, 3, 4, and over 1. And the same all the way up, down, and then I can draw my horrible line that is not straight. And technically I would add my arrows to say that the line would go there. Again, the line needs to be straight. This is incorrect.
Is a coercive act. These all seem like obvious what's grade points. Are they not commonly shared on your campus?
You know, actually I think they are commonly shared. Dozens and dozens of my colleagues. I've been teaching for 41 years now, and I've never seen anything like this before, but most of my colleagues, I think, agree with these basic principles of free speech. I mean, this is just basically free speech 101. Nothing that I wrote with my great younger colleague, Keegan Callanan, in the political science department, nothing here is it's not brain surgery. You know, we were frustrated and horrified by what happened at Middlebury last Thursday and the shutting down of this speech by Dr. Murray. And we got together this weekend and said, you know, why don't we just hammer out what are the basic principles of free speech, more or less for ourselves, and then let's circulate it among the faculty and see if there's some agreement here. And, you know, it took us only an hour to sit down and say, well, what, you know, in 1776, America fought the battle of free speech. These are Enlightenment values, and I'm kind of a free speech fundamentalist, and I believe that the function of the university is to provide a place where those with every viewpoint, left, right, center, and now, of course, it's like the rainbow. There's so many, even on the right and the left, there's obviously a zillion different opinions. I think a university should be, if nothing else, a place, a space, shall we say that contemporary phrase, a space where free discourse can happen, where ideas can clash, people can disagree, and I actually think we're at such an amazing inflection point in American culture right now, because I think people are, I know I am, utterly fed up with the coarseness, the incivility of discourse in the United States. I think we've come to a point, this inflection point, where we have to step back, all of us who are rational human beings, whatever our political viewpoints, whatever candidates or parties we stand for, and say to ourselves, what are the basic principles we agree on here? I mean, we organized ourselves as a nation a couple hundred years or more ago, saying this is a place where we get to talk freely about our ideas. We set up these universities based on Enlightenment principles, and we supposedly adhere to them. I mean, I hope and believe that my own classrooms are a place where students can challenge me and feel free to challenge me. They don't shut me down, and I never shut them down.
Amen. Well, I'm for that. There was one point in here that I thought was so wise, it stirred my heart, actually, and I'm quoting. A good education produces modesty with respect to our own intellectual powers and opinions, as well as openness considering contrary views. This is what is lacking in this debate, is modesty. People believe that their way is right and that no one else could have an alternative view. Do you think that modern university life inculcates that modesty in students?
Well, obviously it doesn't, and I think it's a problem. And I think it's why we have to go back, unfortunately, to free speech 101 and what is the purpose of the university. And I think inculcating modesty, why should we be modest? I mean, I have a lot to be modest about. I don't know that much. None of us do. We all, Robert Frost, I did a biography of Frost 20 years ago, and I love his phrase. He said, we all proceed on insufficient knowledge.
Exactly.
And I think you proceed, I mean, here you are, I'm sure debating with people going over a lot of ideas. You proceed on insufficient knowledge. I'm not accusing you of that because I proceed in my life on insufficient knowledge, and that's why we have to be modest. And, I mean, I think we have to actually teach people modesty. Yes, and I think that's one thing. That's where we have failed. And the problem is we're not really, frankly, seeing modesty anywhere in the culture very often.
No, and that's the key to parenthood, is raising children who know what they don't know.
Between
Really quick,
1 and 2.
how much of your colleague assignments, what percentage would you say of the faculty assignments?
I'd say we're certainly up to a quarter. We've left it open until March 11th or 12th, and every day we're getting another dozen or 2 dozen signatures. I forget what we're up to now, but dozens and dozens and dozens of my colleagues. And what's so interesting, when I
Not real
looked over
sure.
the
Not like that one.
I saw young people, old people. I saw people of color and white people. I saw people that I know are not hard left, but left. People who are not hard right, but right. People who are libertarians. I was really quite thrilled by this coming together. And I think, oh my goodness, we might be at the beginning of something wonderful in this culture. And maybe it only begins when you have a little conflict like we had here last week.
I think that's right. If you get to 65% of the faculty, I want to send my kids there. Thanks a lot. Thank you, Doctor. Great. Up next, we'll talk to a historian and farmer, Victor Davis Hanson, who just wrote an amazing article about why rural voters vote very differently from those in the cities and suburbs. Stay tuned.
I accept I don't race down the slope like I used to. I even accept I have a higher risk of stroke due to AFib, a type of irregular heartbeat not caused by a heart valve problem. But whatever trail I take, I go for my best. So if there's something better than warfarin, I'll go for that too. Eliquis. Eliquis reduced the risk of stroke better than warfarin, plus had less major bleeding than warfarin. Eliquis had both. Don't stop taking Eliquis unless your doctor tells you to, as stopping increases your risk of having a stroke. Eliquis can cause serious and in rare cases fatal bleeding. Don't take Eliquis if you have an artificial heart valve or abnormal bleeding. While taking Eliquis, you may bruise more easily, and it may take longer than usual for any bleeding to stop. Seek immediate medical care for sudden signs of bleeding, like unusual bruising. Eliquis may increase your bleeding risk if you take certain medicines. Tell your doctor about all planned medical or dental procedures.
I'm still going for my best. And for Eliquis.
Ask your doctor about Eliquis.
I mean, I wish I had time to take care of my portfolio, but
Well, what are you doing tomorrow? 10 a.m.
Staff meeting,
Noon?
eating,
3:45?
oh, compliance training,
6:30?
Sam's baseball practice,
8:30?
Tai Chi, yeah, so.
That's relaxing. All right, 9:53.
I usually make my lunches then, and I have a little vegan, so.
Wow, you are busy. But it'd be great if you had investments that worked as hard as you do.
Yeah.
Introducing Essential Portfolios, the automated investing solution that lets you focus on your life.
Vacation rentals? Search Home to Go Florida from $29, Costa Rica from $21, Home to Go Colorado from $32, Hawaii from $24. Home to Go, the largest vacation rental search engine worldwide.
When you're diabetic, one of the important things about keeping yourself healthy is keeping your skin hydrated. Gold Bond Diabetics Dry Skin Relief. 9 out of 10 saw noticeable improvement in just 1 hour. Dry skin is under control. Gold Bond really works.
Long live the courageous, the tenacious, the ones who push forward and give back. Long live the greater good, the helping hand, and long live the truck built to outlast them all. Ram, America's longest lasting pickups.
Now get 0% financing, or an average 11,506 in total values on the 2017 Ram 1500 Bighorn Crew Cab.
How's the new project going? Check it out. Lights.
Meeting configuration.
Blueprints. Call a rooster. We gotta set up a meeting.
Sure. How do you spell it? Abreu, Albert, Allen, Anderson C, Anderson R.
You know what? I'll just tell myself.
Door.
Communications caught up. See why 3,000 companies a month are switching to Vonage. Vonage. Business grade, people friendly.
It's gonna go down to
Bite back fast with tough smoothness. It starts dissolving the instant it touches your tongue and neutralizes stomach acid at the source. Tough smoothies, only from Tums.
It's happening. In just days, Publishers Clearinghouse will be ready to award $7,000 a week for life. $7,000 a week. Week after for life. Don't miss out on your last chance to win. Enter by mail or at PCH.com before it's too late. Hurry, award day is almost here. You could win $7,000 a week for life. Don't miss out.
I can't believe you're denying this. Don't be sneaky. Tell me exactly what you mean. It's something you will only hear on this show. Rural America is clearly voting conservative. They didn't always, but they do now. Why is that? Take a look at the state of California. It was the bluest state, of course, in the 2016 election. But not every part of the state is Democratic. Many counties in the state's Central Valley voted big numbers for Donald Trump. Victor Davis Hanson is a classics scholar and a senior fellow at the Hoover Institution, based at Stanford University. He's also a farmer in the Central Valley. And this wrote a piece entitled, Why the Central Valley Votes More Conservative, where he described the 2016 election as a revolt by the forgotten masses against the elites. It was a revolt, he said, against, quote, a world where walls on the border are proof of ignorant xenophobia, gates and walls around private Tony residences are logical measures to ensure security. Professor Hanson joins us now. Professor, thanks a lot for coming on.
Thank you for having me.
So how would you summarize, so what is the core cultural difference that creates the political divide between rural and urban voters?
I think it has a lot to do with speech and deeds, thought and action. The people in the country, they tend to be a little bit more isolated, and how they dress or how they sound are not as important as what they do. So we've
We've gone now a half century with this best and brightest paradigm where your zip code or your income or the brand of education you're stamped with is supposed to mean something. And we take that for granted. And people out in the country tend to be a little bit more autonomous. They pump their own water. They deal with their own sewage. So a man or a woman that can repair a hydraulic ram in 10 minutes or get on their belly and take out a transmission, that takes a lot of skill and it takes a lot of intelligence and ingenuity. And we haven't valued that because we are in this paradigm. You leave this Tony prep school, then you go to an Ivy League or a Stanford, and then you get...
Here we have y equals negative 2/3 x plus 2. The slope here is negative 2/3. We don't have to put it over 1 because we already have a fraction. And the y-intercept is 2. So our rise is going to be negative 2, which means we're going to go down 2. And 3 means the run is that we're going to go over 3. So our y-intercept was right here. We're going to go down 2 over 3, down 2 over 3, down 2 over 3, and then reverse it up here, and then we can draw our line through there. Hey, that's a bit better. I don't know why the stylus won't draw a straight line. Now we might look at how using a linear model using the function y equals, and here's the example, 1.9x plus 350. And this is kind of like, 1.9. So the slope, like I said, is 1.9. The y-intercept is 350. 1.9 equals 1 over 9/10. It's 9/10 equals, we turn it into an improper fraction, it's 19/10. We can round up 19 for the purposes of this, so I use my squiggly lines, and I can get 20 over 10 for my slope. And this one was really hard to draw. I didn't set it up right. I used my little zigzaggy things here to indicate that I'm jumping numbers. And I have 300, 350, 400, and 450. It's kind of hard to read my writing. The y-intercept is at 350. That looks like 310, but it's really 350. We're going to go up 20, which is hard to do on this, and then over 10, up 20, over same, up 20 over 10. At the question, and so right here we have the question that we were looking at here, which is in your book, is Chai has a small business making decorated hats. That goes with that picture on the front cover page. Based on data for the last 8 months, she calculates her monthly cost, Y, of producing X number of hats using the function Y equals 1.9x plus 350. So here she had Y is the cost of producing hats. The 1.9, we have the X, which is the number of hats, and 350. So she's using this function, she can figure out. And if she does 35 hats, so what you can't really see here is that this is a 3. It doesn't really do it. And for some reason, my stylus will not write a 3 there. So it's we have 10, 20, 30, 40, 50. We were asked to figure out the cost for 35 hats, and that's what this blue line here is marking right there. And so from the graph, we can see that the cost of making 35 hats, although you can't see it here, is that it would cost about $416.50. Parallel lines, these are lines that never intersect. What is the line? Or it says here, what is the, wait a minute. I don't know why my little arrow isn't working. Parallel lines are lines that never intersect. Sorry, I don't know how many times I said that. So what is the slope of the red line? Well, it gives us the answer is 1/2. It's actually, you can see it's increasing. It's going over 1 and 2. What is the slope of the blue line? And it is 1 over 2. So that's the rise and the run. So parallel lines have the same slope. They're the same. So how would you identify parallel lines? Well, ignore all this. I'll walk you through this. It kind of looks messy. So identifying parallel lines. So we have line A, which is the equation negative x plus 2y equals 6. Line B is negative x plus 2y equals negative 2. Line C is x plus 2y equals 4. So right here I did line A is negative 6 plus 2y equals 6. I subtract the x from both sides, or add the x to both sides. That would leave me with 2y, and then I'm going to rewrite the x to be first after the equal sign. So I have 2y equals 1x plus 6. Divide everything by 2, so that's 2y divided by 2, 1x divided by 2, and 6 divided by 2. And then that leaves me with y equals 1/2. It's hard to see. That's 1/2. That's my slope. I circled it in blue. 1/2 x plus 3. 2 divided into 6 is 3. So my slope here is 1/2. On line B is right here. It's negative x plus 2y equals negative 2. I add an x to both sides. And so I'm left with 2y equals x minus 2. I divide everything by 2. And so that 2 into 2y leaves me with y. 2 into x, that would be 1x. I just didn't put the 1 there. So that's going to leave me with 1/2. And 2 into negative 2 is negative 1. And so my slope here is 1/2. And the last line is x plus 2y equals 4. I subtract an x from both sides because I'm trying again to isolate the y and then just get it into the slope-intercept equation. I have 2y equals, I reformat my line so that the x is first. So I have 2y is 1x plus 4. I'm going to divide that by 2. And I'm left with, and this should have a negative up there. I noticed that right here. It's missing a negative sign right there. My answer then is y equals negative 1/2 times, or plus x plus 2. And so line A was 1/2. So I hope I haven't lost anything. Okay, B is, by golly, B is 1/2 and C is negative 1/2. So the two that are alike is that have the identical or have parallel lines that have the same slope. So it may have different coordinates, and we can see what over here the y-intercept is 3, so it's going to cross onto 3. And over here, this one was crossing at the 2, and this one is crossing. That was weird. It had duplicated my page, so we have here 3x plus 2y equals 6. We're going to look at the lines again. So we have 3 lines. We do the same thing. We have to get them into slope-intercept form. So I subtract 3 from this side, negative 3 and negative 3 here. And then I end up with 2y equals negative 3x. Again, I put the x closest to the equal sign, plus 6. This is, I divide everything by 2. I am left with y equals 3 over 2. And I won't put this over 1 because I already have the rise and the run here. Plus the 3 is the y-intercept. Down here I have 3x minus 2y equals 6. I subtract 3x, negative 3x from both sides. I divide everything by negative 2 to get rid of that negative sign. And I will have, I get left with, when I work it out, y equals 3 over 2 minus 3. And my y-intercept here, my slope is 3 over 2. Over here I have 6x plus 4y equals 6. I subtract both from both sides negative 6x. I end up with 4y equals negative 6x plus 6. Again, I put it in the proper format. Divide everything by 4, and I have y equals negative 3 over 2 plus 3 over 2. And the ones that match are these two, and so these two would be parallel lines. Again, watch your negative signs, and when you're multiplying and dividing negative by negative. This is a picture of the first cable car that in 1873 appeared in Nob Hill in San Francisco. How would you like to have ride on that every day to work? It rolled down the slope at a stately pace of 9 miles an hour. By 1890, San Francisco had 8 cable car companies, and they were running, which is 600 cars. So in 1890, they had 600 cars covering more than 100 miles of track. That's a lot. And we could actually use this. You don't get assigned to this problem, but there is a problem where that involves cable cars, but I didn't assign it to you. Your assignment is on pages 246 to 249. It's number 4 through, that's 14. That's kind of hard to read. This is 14 through 16, 20 through 22, 29 through 31, 39, 40, 50 through 54, even, 59, 60, 67 through 69, 70 through 88, even. And again, that's 14 to 16 up there that looks kind of gobbledygook.